I'd like to welcome you to our university's Computer Science Club Artificial Intelligence Conference.
İyi günler. Hepiniz hoş geldiniz konferansımıza.
Firstly, we would like to invite our president, Mr. Emery, to thank you to explain the certificate of participation.
Sayın hocalarım, değerli konuklar ve sevgili öğrenci arkadaşlarım, sizleri üniversitemiz Bilgisayar Bilimleri Kulübü adına selamlıyorum. Yapay Zeka adlı konferansımıza hepiniz hoş geldiniz. Öncelikle sertifika programı hakkında konuşmasını yapmak üzere kulüp başkanımız Sayın Emre Tüfekçi'yi kürsüye davet ediyoruz.
Hello, all of you, and I would like to introduce our certificate program. We will show you QR code firstly, and you will reach this page, and bottom of this page, reading status. And if you get this, status is success, so this means you passed the first test successfully. If you reach this page, please return back and refresh the page, fill the form again and send it till you reach the success text. Next one is our QR code. Please take a photo of QR code and reach the page for getting the certificate. And you will do this form, you will fill this form 2 times, and the second one, I'm not sure, maybe end of the seminar we will show you again, and you will do same steps, exactly same steps again, and if you do successfully both of them, you will get the certificate from us. Okay. Thank you for listening.
We will now watch our promotional video.
Konuşmasını yapan Sayın Emre'ye teşekkür ediyor ve tanıtım videosunu izliyoruz.
Do you want to improve your computing, networking, teamwork and communication skills? Don't ever worry. The Computer Science Club at our university is supporting you to bypass all these problems. We are glad to introduce the Computer Science Club, a big community for you all.
This club was established to organize many conferences and panels. Secondly, to build a strong relationship between students and to organize many social trips, like Kantara Castle or the Golden Beach. Also, to represent CIU in many club activities. Lastly, to provide the students with support in classes and much more.
Anyone is invited to join us. Please invite all your friends. You can find us on the social media sites. You can register by using the provided QR code.
We invite
Hello
our
everyone.
We invite our guest, Dr. Shadi Evren to speak about artificial intelligence and the future.
Yapay zeka ve geleceği hakkında konuşmasını yapmak üzere Sayın Doktor Şadi Evren Şeker'i kürsüye davet ediyoruz.
Okay, hello everybody. So today the plan is starting with the English session first, and then after a coffee break we are going to continue with Turkish. So if you are waiting for the Turkish session, it's going to take about an hour. Türk olanlar için söyleyelim, bir saat kadar sonra Türkçe bir session başlayacak. Orada Türkçe olarak konuşuruz. But first I'm going to start with an introduction to artificial intelligence and the things I'm doing in the research area or in the industry. So I'm going to try to open the perspectives of artificial intelligence and the big data or the data science. And I'm going to try to keep it very fast, and I'm going to leave about half an hour for the questions and answers, so you can ask any questions or you can just ask for discussing anything. So you can ask anything, by the way, but I'm not sure if I can answer all the things, but you can try your best. But let's start with the brief history of the artificial intelligence. So we are going to start with the discovery of nature. So the humankind is discovering the nature and the invention of field. These two events are very important. Actually, the discoveries in the nature and the inventions. So basically, the distinction between the artificial intelligence and all the sciences depends on this distinction. So first of all, invention of wheel is something never exists in the nature. Okay, so maybe you can discover the fire, you can discover something useful as a tool, but invention is a completely different story. So first time humankind is bringing something never exists in the nature. So for example, you can think about mathematical or geometrical imaginations. So let's consider the concept of point. I'm sure you all know something called point from the geometry classes, but point never exists in the nature. It's something dimensionless. There is no dimension of point. So we can talk about something imaginary. We can have a cognitive level of understanding or cognitive level of thinking. And furthermore, we can transfer this cognition from one person to another person. We can write computer software, we can write some mathematics books, and we can transfer this knowledge from one person to another person. So here we have the separation of science, perhaps. On one hand, we have the logical scientific background. On the other hand, we have the empirical scientific background. It's coming from the philosophy or the physics. So the separation of these actions, actually the computer science is on this hand, on the left-hand side, coming back from the philosophy. We have logic, and from logic we have mathematics, and from mathematics we have the computer science. And of course, artificial intelligence is a subfield under the computer science. So all the things I'm going to talk about for today is starting from nature, going up to the cognition level. So we have nature, discoveries on the nature. We have hardware and electronics. Perhaps electronic engineering or electrical engineering is working on this level. And above this level, we have the software level. We are writing computer softwares. We are preparing computer codes or programs. And it's about the mid-90s, starting with the Turing machine. So all the computer softwares we are creating for today, all the softwares are a Turing machine actually. All the languages are going back to the Turing machine. And beyond this level, we have artificial intelligence. In the artificial intelligence level, we are talking about something the computers or the machines are doing instead of a human user. And I'm going to finish with the cognition level. So we are going to talk about what do we have in the cognition level just above the artificial intelligence. So let's start with the correlation versus causation. It's the first thing we need to separate when we start discussing about artificial intelligence. So the machines are thinking in a different way than the human. Okay? So most of the time, if I'm asking you something like, do you know something? Then this means we can just interpret it interpret this like, do you know the reason of something? Okay? So for example, if I say there is a relation between the ice cream sales and the shark attacks, the first question might be why? Okay, why they are correlated? Okay? This is how the humankind learns or thinks. But for the computers, it's actually not important. Okay? For example, in data mining courses, we start with the very famous sample, the beer and the baby diaper. So the sales are correlated. So any customer comes to the supermarket, buys the baby diaper together with the beer. So the first question might be why? Why do we sell both of them together? What is the relation between these two items? But actually this is not important for the computers, for the machines, for the artificial intelligence. Because if you can sell them together, then just sell them. Okay? This is how we solve the problems in the computer science world or the artificial intelligence world. But if you are curious about the relation, actually they are both related to the sun, and the sun causes the ice cream sales and the shark attacks together, so there's a correlation between them. But the computers or the artificial intelligence can work without the causation behind it. Okay? Only the correlation is enough for ending up with some working systems. Okay, so there are 4 types of economic models. The first one is coming from the primary activities, so you can think about the landscape. The first economical activity is related to the land. You can think about the farming, agriculture, or mining. And the second one, we are talking about we are talking about industry, production. So the second industry is related with the production, factories, industry, and so on. And the third one is related with the service industry. You can think about the finance, banking, or cafes, or any kind of service industry in here. But the fourth one, the quaternary activities are related with the knowledge. So we have a new concept called knowledge economy. This knowledge economy is producing something useful in the knowledge level and selling this knowledge only. So we can think digitalization together with the knowledge economy. We are talking about knowledge workers. We are talking about an industry built on the knowledge. So all the people in here can be considered as knowledge workers because you are going to learn something and you are going to produce something in this knowledge level and you are going to sell this knowledge in the industry. So the things I'm doing are very related with the big data. So the main concept I'm working on is the data science, but they are together with the big data and artificial intelligence. So the motivation is built on the data science, but we are working in a big data environment. So let me start with introducing the big data. We have 5 V's for the definition of the big data. The first one is the volume. So you can imagine about the social networks like Facebook or Twitter, and there is a huge amount of data that you cannot store in a single computer. So basically it's just the volume we are storing in a data center, let's say, which is built on more than 1 computers. The velocity of data is fast. So today we are producing lots of information, lots of data, and we need to create a technology to handle the speed. And the third one is the variety. So we have different types of data, like the images, videos, voice recordings, or text messages, and so on. And the veracity. We cannot trust, we cannot yield, we cannot rely on the data. It exists in one site, and this website closes and changes the concept and so on. So basically we are defining big data with 5 V's, but you can only see 4 V's in here, and the 5th V is the value. So if we can convert these problems, if we can just solve these problems in any institute, let's say in a company or in a firm, we are trying to produce the value. Okay. So also we are working on a Industry 4.0. It's a very famous term nowadays. It's starting with the mechanization in the first generation and then mass production. So you can think about the steam engines in the first generation, the industrial revolution in the second generation, and the computerized manufacturing or computerized industry in the third generation. Now we have Industry 4.0, which you create some factories without any human interaction. So they are all automatized, and the machines are solving their problems if there's any problem. So Industry 4.0 is also related with big data, data science, and artificial intelligence. Here we are talking about the IoT, Internet of Things, which is created by the machines only. So the internet for today is the internet of people. So we are using internet for our own purposes, like we have social media, social networks, search engines, and so on. So basically a search engine designed for a human search, and we go to the Google and search for some key terms and we get some results. But in the future, in a very near future, we are going to talk about the internet of things, where, for example, your car is going to search for a suitable parking place or is going to search for a charging spot on the internet. So we are going to see some search engines designed for the machines. So here you can see the several layers of IoT. So it's basically starting with the edge sensors or actuators, where, for example, let me give you this picture in here. You can see the self-driving cars of Google or driverless cars. So basically here you don't need a driver. Still you have a steering wheel or some hardware for controlling the car, but basically it can go any point without any driver interaction. And here you can see a social network of the cars. So basically, for example, if there's a problem in this road, if there's an accident, you can get this information very early, so you can get some precautions, or you can also get a social network between the parking lots or charging stations and so on. So here you can think about the sensors on a car and the connection layer between these sensors and a computation layer, for example, a CPU or a microcontroller on the car. So the car can take some actions related to the data coming from the sensors, and it can also send back to some actuators, like increasing the speed or stopping the car or changing the gear. So we can consider these things as actuators. All the information created in these three layers are stored in a central point, in a central data center, let's say, a server. So here comes the big data. Okay, so we are talking about big data after this point. Think about many cars driving on the road. They are sending information to a data center, and you need to accumulate all this data in a single server. So let's consider this social network in here. Everybody is sending some information to a center, and this center is taking a reaction, taking some actions related to the data collected from the field. And beyond this data accumulation layer, we have an abstraction layer. In the computer science industry, computer engineering, we have the abstraction layers to just separate the data layer from the application layer. It's a very general tradition. We use these abstraction layers for changing the data layer without touching the application layer or vice versa. So here, there's a data abstraction layer, and we have all these applications running on this abstraction layer. And in application layer, you can think about some BI, business intelligence applications like dashboards or scoreboards, or you can have some intelligent softwares running on this big data. For example, you can search for any problem on the road, any problem related to one of these cars, and so on. Okay, I'm going to go a little bit faster. So this is the logistics center of Amazon. They have they don't have any logistics center yet, but they are planning to create it. And you can see the drones of Amazon in here. So in the logistic industry, probably you are going to see a completely mechanized and automatized system very soon. So they are planning to send these packages to the delivery points with using these drones very soon. Actually, they have the technology, but they are just delaying it because of some political issues. And a smartphone application, maybe you heard about Amazon Echo. So basically you can ask something like, play me jazz music, and then it's going to find the best jazz music suitable for your experiences on the internet, and it's going to play it. And I'm not sure if you know this computer, what's called as IBM Deep Blue, and it's the first computer beating the world chess champion in 90-something, I'm not sure, but it's just 20 years ago, 20 or a little bit more perhaps. And this is Commodore 64, and this is the navigation computer of Apollo to the moon. And both has 64 kilobytes of memory. The RAM, random access memory, is 64 kilobytes for both of them. So today we have a boom on the hardwares. So what we do in the industry or in the academy can be just interpreted as monetizing data or creating value from the data. So we have data as the raw resources, and then we try to produce some value from this data. For companies, most of the time this is the monetizing data. So basically you collect data from everywhere, data is everywhere, and we try to create something useful through this data. So here we need to talk about data science. Data science is a subfield under KDD. KDD is knowledge and data discovery, so it is related with computer science and artificial intelligence. So we have machine learning as a subfield of artificial intelligence, and AI is a subfield of computer science in general, of course. We have statistics, so we use some methods or models from statistics, and actually there is no intersection between statistics and machine learning. This is a very important point for us, because you cannot interchange, you cannot use statistics and machine learning at the same time. You can have some good models from statistics, you can have some very good models from machine learning, but you cannot have both of them at the same time. You need to pick one of them. And we have databases and data processing. Of course, this is switched by big data now. We have data mining in here. We use some techniques from data mining. We have visualizations and neural computing. Of course, today it's a very famous study area in neural networks, artificial neural networks, and deep learning. And this is an end-to-end story for data warehouses. It's a transformation in the industry. You start with many data sources. For example, you can have this data source for customers coming from the loyalty cards or web store, or let's say from the bank transactions. At the end, you have many sources of data. We have ETL processes in here to extract a useful information from different data sources to collect them into a single data source. So for example, you have the customer name and address in the customer database or web store or let's say loyalty card, and then you end up with the same address after the ETL processing here. We have OLAP cubes, or we have some BI tools working at the end of this story. So it's taking about a year, maybe more most of the time, for converting a company from the classical data processing units, I mean the core databases, to the data warehouse and ending with a BI, business intelligence application. Let me ask you the question. Any of you see this picture before? Any of you? Never? I couldn't find the picture for Cyprus or any city in Cyprus, but what if I say this is a map of Istanbul? So this is the sea, the Marmara Sea, and these are the islands. There's a Bosphorus in here. This is not a satellite or air photo. Basically, this picture is created with the points people tweeted in last day. So you can collect the tweeting points, and then you can create a map like this. Okay? So this map, I mean, the data we process in here is called as non-obvious relationship awareness. So basically, we try to create some relationships between the data we have collected. And actually, you cannot see it in at the first glance. So it's basically after some data mining and data processing steps. Basically, the Twitter is created for messaging in 140 characters, or 285 now, right? I'm not sure. They have updated it. But the purpose of Twitter is not finding the locations or creating the maps or so on. But you can use data for many purposes. So data is a strategic resource now that you can use for your own goods or for the goods of your company, or you can produce if you are capable of using it for your purposes. Okay, let me talk about the scaling now. So this is called NoSQL. It is not it's just the shortcut of not only SQL. So basically we have two types of scaling. The first scaling, the traditional scaling, is the vertical scaling, and if the data is getting bigger, you need to increase the size of your servers. So you need a bigger server, you need bigger license agreements, you are storing more data on a bigger box. But the horizontal scaling is something new, which we created in the NoSQL era with the big data studies. So if the data is increasing, don't increase the size of box, but instead put some new boxes besides the servers. So it's called as the horizontal scaling, and it's very important for the big data studies and the big data analytics. So this is called as MapReduce, and if we can have more than one servers for holding data at the same time, then we can just use it for localizing data. So for example, think about Facebook. You have users from China, you have users from US, you have users from Turkey, and then if you can put data in more than one servers, you can distribute these servers to the closer locations to your customers or your users. So a server holding user information from China can stay close to China. A server holding user information from US can be located a close location to the US. This is called as localization. And here we can just distribute the workloads, or we can map problem to more than one servers at once. So think about a problem. Let's say you have a web page which is holding the real estate prices, let's say, in Cyprus. And then you can distribute this server into many sub-servers. Let's say you have thousands of servers, okay? So this is called as the distribution of MapReduce. Let me ask you a simple question. Let's say you have an unordered list with n elements. If you want to search the minimum price on this unordered list, what is the worst case analysis for searching n element list? Any answer for this question? Let me ask it one more time. So you have an unordered list with n elements, and you are going to search the minimum number in this list. What is the worst case analysis for it? Let me ask, how many numbers of elements do you need to check to find the minimum number of this unordered list? Yes. Of course you. Okay, your student is better to answer. Yes, your answer. Exactly, whole list, not probably. So it is, I mean, the worst case is n. Right? If you have n elements in an unordered list, you need to check for all the list, as you say, the n elements. So let's say you have millions of real estate advertisements on this web page, let's say, then you're going to check million advertisements. So what if we divide it to 1,000 servers? Let's say we have 1,000 of servers in this pool, and you're going to distribute this equally, and let's say each server is going to hold 1,000 advertisements only. Okay? So you can just divide this process, and you can ask all the servers to find the minimum price real estate on their storage. Okay? So each server is going to search for the minimum price, and then it's going to take 1,000 search. I mean, you have 1,000 members in here, 1,000 advertisements in here. So the search time for each of them is 1,000. And in total, you have 1,000 servers. So it's going to be 1,000, and then you are going to reduce. You are going to collect the minimum prices from each servers, and you are going to search for another 1,000 in here to find the minimum price after this mapping operation. So it's going to be 1,000 plus 1,000, 2,000 searches for 1 million advertisements. Okay? So in this new approach, we have 2,000 search instead of 1 million search. So the time is reduced. Okay? So this is the power of MapReduce. You can map the problems into multiple servers, and then you can reduce the results in a single result output in here. Okay, so these are the technologies. Let me talk about the disruptive science related to the big data or the data science. So the science is changing. The things in science is changing. So first of all, the social sciences are very related to the surveys, okay? And actually the surveys are related to the sampling, because each time you do a survey, you are making a sampling, Okay, you are collecting some demographical information, you are sampling from each of these demographic groups, and then you try to forecast or you try to predict the overall result for this society. But big data is changing the game in sampling, because after the big data we don't need sampling. Okay? So let's consider a survey about the politics. Which political party is going to rule in the next election? Okay? So this is a simple question, and everybody is paying for the answer of this question. And you are doing some surveys, some questionnaires about the next political election. So here, you are just collecting some samples from each demographic group, let's say each gender, each education level, each income level, and then you try to predict the overall result of this election. But what if you can understand the exact political view of each Facebook users? Okay? And let's say in Turkey, for example, we have 40 million of, I think it's 50 or 60 million of Facebook users, and you can predict a better result than sampling by survey. Okay? And actually we can do this. Actually we can just measure the reaction of each user after each event. So let's say there's a speech of president, and we can just measure the reaction of each user after each speech or each event in the news. So we don't need sampling anymore. Or in the marketing, for example, we can create some recommender algorithms. Okay, for example, maybe you heard about the company named Amazon. So Amazon has 35% of income from a recommender algorithm. So they created a recommender algorithm. They are just suggesting some products, some items to each customer after understanding the customer behavior. So they are just searching for, they are just trying to understand the customer behavior, and they are recommending one of these items to sell. And the income of Amazon, the 35% of income of Amazon is coming from this recommender algorithm. And for example, for Netflix, did you ever heard about Netflix? They are selling some videos and movies on the internet. The 75% of their income is coming from a recommender algorithm. Okay? So the things are changing after the big data, the data science. The marketing is changing. Maybe we don't need any more marketing. Just we can replace some marketing researchers or marketing people with algorithms. Okay, so let me talk about these analytics. So in the descriptive analytics, we are talking about what happened. Okay, we have 3 layers of analytics, and the first one is descriptive. It started very early, about 50s or 60s, so we use statistics to understand what's happening in the data. It's just basically telling, a storytelling over the data, so we try to use dashboards or scorecards to understand what happened. In the predictive analytics, we are trying to understand what will happen. Okay, so in order to make some predictions, first you need to understand what happened. Okay, so predictive analytics is very related to the descriptive analytics. If you don't have a successful descriptive analytics, you cannot create a predictive analytics. But after all, we can just make some predictions about next year. For example, if you can understand how many black t-shirts you sold on your stores, then you can make a prediction how many are you going to sell for the next year. Okay? But the prescriptive analytic is something new. So in the prescriptive analytic, we are taking actions without human interaction. So the computers are making decisions. Computers are ordering something. They understand the data, they predict the data, and then they take the action. They can order some like t-shirts for the stores. They can make some decisions related to the descriptive and predictive analytics. Okay, let me ask this question. How many of you think that the AI is a threat for humankind? Okay, nobody? How many of you think it is not a threat for humankind? Okay, so what about the rest? You don't have any idea about the AI? Did you ever watch a scientific fiction movie related to AI and the robotics? Or how many of you watched a movie called Terminator? Yes. Oh. But you don't have any idea about if it is a threat or not for the humankind, right? Anyway, so basically we have three three ideas in this question. The first idea is, can we create an AI which is smarter than the human? Okay, is it possible to create an AI, artificial intelligence, smarter than human, which can do all the things we do? Any answers for this question?
So far, no.
So far, no. But what about future? Can we do it in the future? Okay, so we don't know the answer yet. But what we know is, probably of course, but what we know is, if we can create something smarter than us, this smarter thing can do at least what we do, right? So we expect them to create something smarter than themselves. This is the baseline, right? In order to declare them as smarter than us. But we don't have any achievement yet. Okay, we don't have such an achievement yet that a computer software or a robot or a computer artificial intelligence can create something smarter than itself. So this is the first threat we are talking about most of the time. So this is called as the artificial generalized intelligence or singularity. Okay? So in artificial general intelligence, we are talking about software and artificial intelligence which can act like human. Okay? So in the computer science, in the first class of artificial intelligence, most of the time we are just making this separation. On one hand, we have some problems, and we are trying to solve these problems with using some rational solutions. So, for example, driving a car. Okay, it's a problem, and can we produce some rational solutions for this problem? So basically, it should be going from one point to another point with the cheapest alternative, the less expensive alternative, fastest alternative, and the safest alternative. Okay. So these are three concerns. We define the problem. But an artificial generalized intelligence is something like this. Can we create an AI which can dance or sing or write a song like humans? Okay? So this is, most of the time, this is out of computer science studies, okay? At least in the undergraduate level. So the first question, the first threat is very related to this singularity thing. The second one is AI can be a tool for destruction. So you can use it for the war industry, the weaponry. You can put some AI on some vehicles. So it can be a threat for computers. It can be a threat for humankind. So they can cause mass killings at the same time, in a very short time. So it can be a threat. But here we need to talk about the threat is not AI itself. The threat is coming from the human using this AI as a tool. Because we all know that knife caused the death of many people. And we cannot blame knife because of that, because the human using this knife is the criminal. Here, we can say the second threat is also up to debate, but it's not the AI itself as a threat. But the third one is a bigger threat. So, from the interview of Obama, maybe you heard about this. The jobs are just replaced with AI and machines. So here you can see a chart, and this is a research, and it has a very good reference. But basically it says that the majority of the jobs will be replaced with AI or machines in the near future. So basically 80% of all the jobs will be replaced with AI. So here you can see, for example, these are the retail salesperson. It's a research on the US, by the way, US market. So it's more than 4 million people employed in this field. And maybe, I'm not sure, maybe 10% of these people stay working in the future. But the 90% of retail salespersons will be replaced with AI. Same for the fast food counter workers. Some of the jobs are more safe, I'm not sure. These are the supervisors and so on. But we can find these research on the internet, and at the end we can say that the AI or the machines are replacing the jobs. So it's a bigger threat. And Do you know that? Without any invention, if we stop inventing something, and if we just replace, if we just use innovation to put these inventions into the field, the 80% of current jobs are in danger. Okay, so the machines are going to replace these jobs in a very soon time. Okay, let me stop in here, and I've just tried to do my best for opening some perspectives about the AI and the data science, so probably it's a good time for your questions in this English session. You can ask anything related to the AI and data science or the big data, of course, but if you have any other questions, maybe we can just take them also. So it's your turn for the questions. I know we are living in an interactive world and you need to touch the content of anything. So you are going to determine the content of today's talk from now on. Okay, any questions? Yes, please.
Do you think that in the future AI will program?
Sorry, one more time.
Do you think in the future the AI will actually...
Okay, you mean AI will replace the programmers?
Yeah, the programming.
Okay, so basically, yes, I can say yes. Because they are going to replace the programmers. The key concept in here, if you will ask, which jobs will be replaced with AI? I can say that if the job is routine, if you are repeating yourself in any field, it can be healthcare, it can be judicial, it can be anything. So if you are just doing something in a routine, AI can replace it very easily. Okay, so in the programming world, there are some routine jobs which you are replacing yourself each time. For example, you create a query in the database, you create a text box, and you pull the data and put it into the text box or a web page. So if it is a routine that you repeat every day, then it's going to be replaced. But if you have a creative job, like if you are an AI programmer or a data science programmer, probably it's very difficult for AI to achieve this level. Okay? Was it an answer for your question? Conscious. Okay, very good. Yes, please.
The difference and relationship between machine learning.
Okay, the difference or the relation between AI and the machine learning is this. AI is a subfield under computer science, and machine learning is a subfield under AI. Okay, so it's a special type of AI. And this special type, I mean, the difference between machine learning and the rest of AI studies is this. Machine learning can learn from the environment, so they can get a better success level by the time. Okay, so we call this reinforced learning or adaptive learning. So they learn something from the environment. So basically, you can start with 0 level of success with an algorithm. I mean, you have a machine learning algorithm and the success level is 0. But after a while, this machine learning algorithm can learn from the environment and get a higher success level by the time. Okay? So machine learning is a machine which can learn. Okay? And under the AI, we can have many different algorithms which cannot learn, but they are still under artificial intelligence. One more question? Yes, please.
Okay. And because there's an aspect of everything. Now, in that regard, you look at AI and machine learning. Which should be the best options in terms of the algorithm? Is it advisable to use an algorithm or to use hybrid?
It depends. There is no exact answer for selecting the best algorithm. It depends the problem, it depends the data, it depends the results you want to achieve. Okay? So what you say is collective learning or ensemble techniques for using multiple algorithms at once for achieving a success level. So it depends. Sometimes an ensemble learning or collective learning is better. Sometimes a single and very simple algorithm might result in a better achievement. Okay? Depends. There is no one answer for all these questions. We don't have a one-size-fits-all. Yes, please.
You talked about risk.
Yes.
Maybe funny. I see maybe possibility that in the future teachers or subjects are going to be replaced by AI.
Actually, there is a discussion about it. I don't know the future. I cannot say anything related to the future, but I can give some idea about it. So, some of these technologies have a barrier of acceptance. We call it technology acceptance model. So, for example, machines can make you a haircut, okay? But after research, we can say that nobody wants to put their hand inside a machine. Okay, so some of them, in the future, we are going to say that it is possible for the machines, but nobody wants to use it. Okay, some of the technologies are hard to replace. So teaching was one of these technologies, one of these areas of study, because teaching requires some skills called interpersonal skills. And the last World Economic Forum, maybe you can find this speech on the internet. Noah Hariri, maybe you know him. He has a book called Homo Sapiens and Homo Deus. So he's a very famous person, academician from a university in Israel, I think. And you can find his speech, and he says that, okay, you're going to have a therapist in the future, and this therapist will be able to get hacked. So somebody is going to hack this therapist. So, which means that, yes, the computers or AI will achieve a level of understanding human, or at least predicting that they are understanding human. But you will get you will still get a gap for these hacking things. Okay? So human finds a way of hacking all the ways. So if you are on the creative side, like hacking or like creating something like related to the art or scientific inventions or so on, so you are on the safe side, at least for today's understanding. Okay. Answer your question, please. So can you understand human emotions? So let me just repeat it one more time. He's asking for the understanding of human reactions and emotions, right? Yeah. So what we do under AI is very related to our level of mathematics. So if you can model anything in mathematics, then you can create an AI or a software for solving this problem. But if you cannot, then we don't know. In the future, maybe, but we are not sure about it. Okay? So all the computer science studies are a subfield under mathematics. So it is limited to our mathematics. If we can create, okay, let me ask you a question. Can you define me the randomness? What is random? There is a very famous paper from Einstein. I think the title was God rolls dice. Does God roll dice? Something like this. I'm not sure about the exact title of it. But the question here is, if you have ultimate knowledge, do you still have some randomness? If you know everything, do you still have randomness? Because the randomness we have depends on what we don't know. Okay? So the question here is, if we have enough knowledge of mathematics or anything, then of course we can model emotions. And we can create an AI for understanding of emotions. But the question here is, are we capable of understanding emotions? Or creating a mathematical form of emotions? Yes. So I'm not sure about it. I don't know.
And I also, it's like when I was searching on AI, question appeared in my mind. In the future, this AI can control the government, for example.
Government?
I think that, yes, because political parties text for the AI in place. Can you imagine that, or do you think it's real?
I'm not sure, but it's very related to the culture. So, for example, for the crime, can you rely on a computer which judges a human to get punished? So it is very related to the culture. But what I know is we are ready to pass over billing to the machines. Because we are doing this each and every day. We are passing over bills to the institute, for example, the companies you are working for. You have an identity over the company, and you are ready to pass your bills to this company. You work for the company. You are not yourself anymore because you are representing the company and you obey the rules of these companies. Or you can think about the machines you carry all the day. So you are ready to interact with the machines, and they are very closer than your best friends. You can take your phone to anywhere where you don't take your best friends. Okay? So the things are changing in our culture. So I don't know what's going to happen in the future, but something is changing. Okay? I can just give some idea about it, but I'm not sure what's going to happen.
Okay, thank you very much.
You're welcome. Yes, we can take a question from this side, perhaps. Or if it is very difficult for the mic, so you can ask the question, and then we can pass it.
You gave an example with the knife. You say that if knife did something wrong, we cannot blame him. So, if, for example, AI did something wrong, who can we blame? Is it the people who created it, or is it the AI itself?
Yes, another difficult question. Thank you for this. Actually, there's a discussion. I think two years ago in the World Economic Forum again, there was a meeting with the CEO of Microsoft, Google, IBM, and so on, and they discussed this question. Somebody asked this question, and they said, okay, let's say a car is driven by an AI, okay? And let's say there's a problem in the mechanics of this car, and AI is going to make a decision. It's going to drive to a crowd, and it's going to cause the death of many people, or it's going to drive through a tree or some, let's say, wall, and it's going to die the driver itself, or the people inside. So, which one is better? Okay? So it's going to kill one person in one choice, and on the other choice, it's going to kill many people, but it's going to save the fifth person inside. Which is more ethical? If you ask this question this way, everybody says, of course, killing one person is much more ethical than killing many people. But if you ask a question like, would you buy a car like this? Everybody says no. Okay? So these questions are related to the culture. These questions are related to the decision and marketing and everything. I mean, these are something called as, I think, yes. So the AI is going to change the future. And we are not ready in the judicial platform, I mean, for the AI. So if there is something wrong, who is the criminal? I mean, AI or the person AI? Of course, in the future, somebody coming from the judicial background is going to decide on this. And what I think is, all the software producers will be responsible for the crimes in here. Okay, that's what I think. But I'm not sure when this judicial reform will start. But in the future, what I sense, something, the judicial platform will change. Okay? It's not ready yet. And you know, these laws and rules are created after a crime occurs. Okay? No rules are written before the crime happens. Okay? So we are going to see. I'm not sure. Yes,
okay, thank you so much for the opportunity. I wanted to find out about how big data companies have been given so much power to monitor our emotions and our routines and what we do. Don't you think that a monitoring board should be set in place? Like
monitoring what?
A monitoring board. Like for instance, they should answer to someone. Like this is Facebook, Snapchat, Twitter, and all this. They monitor us on what we do, where we are, what we're doing.
It's not ethical, of course.
It's not exactly.
It's against the privacy of humankind, okay? But they are very powerful. They have all the information. So, okay, every company is founded for making profit. So, they can use any tool for increasing their profit, of course. So nobody can blame them for trying to do their best for creating profit. But on the other hand, we have governments for balancing these things. Okay? So we have police force, we have judicial issues, and so on for balancing these companies. Without these governments, we don't have any balance. But now, the things are changing because the companies are very powerful. They have much more power than the governments. So even the best country, best government has a limited force on a geography. Okay. So for example, in the US, they have limited authority on this geography. But the companies can go to any country. They can just go, or they can even create some data centers on the ships with the inter-country borders. So they are going beyond the borders of any country, and they create some data centers over there to just increase their profits or do their best with the data. So the problem here is, I think, in the future we need something to balance this force. So the things are created. I mean, something is appearing. Like maybe you heard about the Bitcoin or the blockchain industry. So it is something a little bit of anarchic. Okay? So they go against the government. They go against the rules of any government. Maybe in the future we are going to have some technology to balance these unlimited power. Okay? Because of course they have some biological limits, but after all they have no limits if we don't do that. Okay? So from the ethical point, from my point of view, it is unethical, of course. But how can we control it? I don't have an answer. But I feel something would happen. Okay? Maybe you can pass. Yes.
According to my own understanding of being cognitive and being intelligent, there are two different things. So I'd like to know if it is part of the dream of AI development that it becomes fully aware of itself, of its own self, to be cognitive.
Yes, this is called as singularity. I mean, the concept called as singularity, the question you're asking, the full awareness of itself, self-esteem, and so on. But we don't know the answer yet. There are many people working on it, and we have some, maybe you heard about IBM Watson. There's a project called as Watson, maybe you can search for it on the Google or on the internet. They are trying to create some AI. For example, you remember the Deep Blue, which beat the world champion in the chess. So if you ask a simple question like, who are you? This computer was unavailable of answering this simple question. So there are some projects going on, and in these projects they are trying to create some AI which can answer, which the AI is self-aware, but they are still in a very early age, and we don't have any good results yet to achieve these levels. Actually, the question here is, can we beat humankind with AI? Okay, the question, so how can we say that this AI is better than human? Who's going to judge this? We have a test called Turing test, and this Turing test is something like this. You have two monitors in here, and behind one of these monitors you have an AI, and behind the other monitor you have a human. So you can ask any questions to these two monitors, and one of them will be answered with the AI, the other one will be answered with the human. So can you understand which one is AI and which one is human by asking questions? Okay. So if you cannot, then we can say that AI beats human, because AI is just acting like a human. But here, the judge is human itself, right? So the human asking questions is the judge. So we don't have any objective criteria for judging if the AI is successful than human. Okay. So this is the main problem we have. We don't have any test bed yet to beat. Okay. So in an area we don't even have a test bed. We cannot say the human is going to pass, the AI is going to pass human. Okay. It's a very difficult question to answer yet. Answer your question, please. Let's take the last question, and then we are going to have a coffee break.
Earlier you said that artificial intelligence is taking over most of the jobs, and my question is basically, isn't it like creating other jobs that we just need more technical abilities to take?
Exactly. So the technology just finishes some jobs and creates new jobs. This is the history, right? It It repeats all the time. So for example, think about banking. Without ATMs or internet banking or mobile banking, we need more employees in the bank branches. So maybe if you have 50 million of customers, then you are going to need 10 times more people working on these branches for keeping the archive, for keeping the bank accounts and so on. But after the computers, we have ATMs and internet banking. We don't need these people anymore. So you employ less people for the same job, but it creates a new job like internet softwares or mobile software creation, I mean the mobile programmers or internet programmers or ATM machines and so on. So it finishes some of these jobs and then it creates a new type of job, right? It happens in the past, but we know that the new jobs created by technology is always less than it kills, it finishes. Okay? So it's like a bottleneck, it's getting narrower and narrower each time. Okay, so this is the problem. This is why we have AI as a problem in the job market. Or if you have any objection about it, maybe we can discuss.
Also, like, whenever a computer passes the Turing test, the test proposed by Alan Turing, can it be said to be self-aware?
At least you need to have self-aware for passing Turing test, of course. It depends who you are going to sit for asking questions, of course. But if you sit somebody intelligent enough, so you need at least have a self-aware software to pass this test. You can ask a simple question like who you are, why do you exist, or some questions like this, and then after a few questions you can understand if it is a human or not. These are some basic questions we need to pass. Okay, so maybe we can stop here for the coffee break, and after the coffee break we are going to go to the Turkish session. Thank you all for listening.
Kayıt. Good.